All right, so let's start this off with number one here. So it says a rental car company is charging $30 a day and 15 cents a mile for renting a car. So I would actually just start off with the cost of renting a car using variables. I would use C equals, all right, and then they said $30 times the number of days that you rent the car plus 15 cents per mile. However, I can't put 15 there because it's 15 cents versus $30. So to make this both in terms of dollars, I'm just going to go ahead and put a decimal there, so it's 0.15. Okay, so the next step, I'm just going to kind of plug in everything that I see here. So it says she rented it for 2 days, so we know that the D is 30, or sorry, it's 2. 30 times 2 is what I was thinking of there. And then the bill comes out to $108, so the cost is $108. And so now we can go ahead and solve it here. The M is the only variable left, and that's good because that's what they're asking about. You can see how many miles did she drive. So whatever they're asking about should be your variable left over. We have one equation here with one variable. That's always good. We can always solve for one equation with one variable. If we have two unknown variables, we're going to need two equations. We'll actually get to that on the next question. So what I would do next is I would subtract the 60 from both sides. I'm kind of doing that 30 times 2 in my head there to cancel that out. So that'll be 48 equals 0.15 m, and then I would just divide by the 0.15, and on the calculator that'll cancel out, and this would be 320 equals m, and so that would represent 320 miles that she drove. All right, next one here, it says Mary inherits $1,000 investing into two different stocks. All right, one gets 6% and one gets 4.5%. And then her total earned on the year was $50.25. Okay, so I'm just going to use you're going to need two variables here. We're going to need X as the amount invested in the 6% account. And then Y will make that be amount invested in the 4.5% account. Okay, so the first equation has to do with the $1,000 that was invested. So it does not say that it was $1,000 invested in each of these accounts. It says it was $1,000 total. I cannot assume that it was split evenly, 500 each. They're actually asking me how much was invested in each account, so they're not going to tell me that. So my first equation, though, would be if I add these together, they said that the total amount invested, so X plus Y would be the total amount invested in each account added together. That adds up to 1,000. All right, so then my next equation here is going to have to do with the percentages. So I'm going to multiply each of these accounts by their percentages. So for X, that's going to be 0.06X plus, and then for Y, it's 4.5%. Now be careful, that's not 0.45, that would be 45%. It is 0.045Y equals, and then the total amount that she earned was $50.25. What I always like to point out here is try to notice here that the relationship between these variables and what they equal should be logical. So for this one, it's like if I have 1x plus 1y, it equals $1,000. So then when I multiply these variables by these little decimals, this number is a lot smaller than $1,000, and that makes sense because if you multiply by little decimals, your numbers should get a lot smaller here. There is actually another way that I'd like to point out that we could write that second equation. So I'll go ahead and write this like over here, and so that way what you could do here is you can write it as, I'm going to have to do this kind of sideways here, but we could write this as 1.06x. Let me write that a little bit neater here, 1.06x, and that would be like I take the 6% that I earned and add it to the one that I started with, and then I could do 1.045y, so that's kind of just adding the 4.5% to my account. And what this number would equal is actually the $1,000 I started with plus the extra $50.25 that I earned. And so you can see on that one, my logic still makes sense there. If I'm multiplying these variables by 1 back here, it equals $1,000 when I add them together. When I multiply them by these numbers that are a little bit more than 1, we get an answer that's a little bit more than $1,000. So that's another way to do it, kind of thinking of it as adding my new money to the money I already had. You can use either one. I'm going to go ahead and use the one I already wrote here. So what we have here is two equations, two variables, and so I would use a system of equations here. So for a system of equations, you can solve by elimination or substitution. I would use elimination here. Anytime it's like the variable plus variable equals number setup, we can multiply by a number that's going to eliminate one of the variables. I would multiply by negative 0.6 and write that underneath here on that first equation. So that's going to become negative 0.06x minus 0.06y equals negative 60. Just multiplying everything by negative 0.06 there. And the reason I did negative 0.06 is that now I can cancel out these... I can cancel out the x's here and eliminate them, which is the name of the technique. I'll add down my y's. You can use a calculator to help you out on that, but I know it's negative 0.015y. And then I'll add together here 50.25 minus 60, and that's negative 9.75. Okay. So then my next step here, I would divide that negative 0.015 over. Don't really have space here, so I'll do it over here. I'll just say y equals negative 9.75, and then dividing that negative 0.015 over. Once again, we want to use a calculator for that one, and so I got y equals $650. So that means Mary invested $650 into that 4.5% account, which was identified as y. All right, so now I got to find out what x is, because it did ask me for both variables here. So for that, I would take that answer for y. I would plug it into any equation. Looks like this one's probably the easiest equation to do here. The x plus y equals 1,000. So I can just say like x plus 650 equals 1,000. Subtract the 650 over, and x must equal 350. And so there is the two amounts that I invested in each account. You can see that they do add up to 1,000, so that's good news. All right, next up here, it says a woman earns 90% more than her husband. Together, they make $179,800 per year. So again here, I'm going to set up a system of equations. I think there's going to be an equation for each sentence. So I'm going to do the second sentence first. I think it's a little bit easier. So this one's saying together they make that much. So that just means the woman's salary plus the husband's salary is equal to that amount of money. We don't know how much they make individually, but we know it adds up to that. Okay, the second one is a little bit trickier here. It's based on the first sentence. It says that the woman earns 90% more than her husband. Now, anytime it says this percentage with a more than or less than with a comparison word like that, we actually don't use that decimal in and of itself. We add or subtract that decimal to 1. So in this case, since it's 90% more, I'm going to think of that as I need to multiply by 1.9 because the 1, just like is the husband's salary, and then the 0.9 is like the 90% more. So this equation I can call a comparison equation. I always put the two things on opposite sides of the equal sign here. So I'm going to put the husband's on one side, the wife on the other side. Obviously, this is wrong right now because these are not equal, but I can make them equal if I just take the 1.9 and I multiply it by something. Now, I'm going to multiply it by the husband's salary. It's a little counterintuitive, but if you think about it here, I have to multiply since the husband's salary is smaller, I have to multiply it by 1.9 in order to make it equal to the woman's salary. You can also think of throwing in a fake number here like 100. So if the husband made $100, we multiply that by 1.9, that means the woman made $190. So that actually does make sense with what the problem is trying to tell us. Okay. This system, I would use substitution because we have an isolated variable here, w. And so what we can do is we can take what that isolated variable is equal to and plug it in for w on the other equation. So I'm going to rewrite that first equation, but instead of w, I'm going to put 1.9h since it's equal to w anyway. And then plus h equals 179,800. And then I would just combine like terms there. So 1.9h plus h is 2.9h. Equals 179,800. I would divide the 2.9 over. All right, and so h equals it would be $62,000, okay? Now, it actually asked me for the wife's salary, so I'm going to take that. I can plug it into any equation, either one of those two original equations. I'll go ahead and plug it into the second equation, so 1.9 times 62,000, and so that means that the wife makes $117,800. All right, so this was 140 coins, nickels, and dimes. This is actually pretty similar to number 2, I would say. And so the first one, I can make an equation based on this sentence. So I would just say like the number of nickels plus the number of dimes is 140. In terms of being this equation has nothing to do with money. It's just like coins. So in terms of being a coin, a nickel is 1 coin, a dime is 1 coin. The second equation I would say has to do with money, and so for that one, it's gonna be based on the $9.60 here. There's 2 ways you can do this. I'm gonna do this in terms of cents. So nickels are worth 5 cents, dimes are worth 10 cents. So I would multiply those, and then that's gonna equal how many cents do I have. Now I actually have 960 cents, converting that to dollars. You could do this using dollars if you wanted to. So I'll do it over here again, and so you could do it as 0.05n plus 0.1d equals 9.6, and so that's kind of saying 0.05 dollars per nickel plus 0.1 dollars per dime equals $9.6. I prefer kind of the way I wrote it in red there because it's no decimals, but it'll work the same either way. This one I would use the elimination again, so I would multiply the top equation by -5 to eliminate the n. You could also multiply it by -10 to eliminate the d variable. Either way, once again, will work fine. Okay, and so don't forget to multiply 140 by -5, so that'll be -700. Now we add these down, the ends eliminate, we get 5d equals 260, and then divide that by 5, so d equals 52. It did also ask how much I have of each, so I need to plug that back in. I'll go ahead and plug it into the top equation there, so n plus 52 equals 140. We subtract the 52 over, and n equals 88. All right, next up here we have a picture frame problem. These are pretty popular. All right, and so I'll go ahead and first I would draw a picture. All right, so we got a poster, and the poster is 100 by 140, and then he wants a frame to go around it. Now, whenever they have the frame here, the frame is always what we call a uniform width. And so what it means is like the distance from here to here, from the edge of the poster to the edge of the frame is x. And then going this direction is also x. And then going this direction is also x. And then going down here is also x. Just any distance from the edge of the poster to the edge of the frame is x, okay? Okay, so what they say here is that he wants the perimeter of the frame to be 1.5 times the perimeter of the poster, okay? So I'm going to call that like P sub frame. He wants it to equal 1.5 times the perimeter of the poster, okay? And so what I would do here is I would first find the perimeter of the poster, since that's kind of a known thing here. So remember, for the perimeter of the poster, I can do perimeter equals 2L plus 2W. And so the poster, I already know the length is 100, and then the width is 140. So if I type that all into the calculator, that means that the perimeter of the poster is 480. And so I'll just call it P sub F then, so for a frame, equals 1.5 times 480. And so he wants the perimeter of the frame to be, whatever that is, 720, okay? Okay, so now that we know that, we need to do a new equation for the perimeter of the, frame. Okay, so the perimeter of the frame is, again, 2L plus 2W. Now, I know that I want the perimeter of the frame to equal 720 degrees, okay? And so I'm going to do that as 2 parentheses. And what's the length of this? Well, if we track the length of the whole frame here, you can see actually the length would be this way. It's more than 100, right? We'll actually track it right here. So this red line, the poster is 100, and I have to add that x over there, and I also have to add that x over there. And so what that's going to be is 100 plus 2x, because we have an x on each side added to the 100 in the middle. And that's the same thing going the other direction. So this red line in the middle is 140, but there's also another x down there and another x down there. And so the width of the poster is 140 plus 2x. All right, so now I just need to solve this for x. I would go ahead and distribute the 2's in there. So 200 plus 4x plus 280 plus 4x. All right, I would combine like terms, so 480 plus 8x equals 720, minus the 480 over. So 720 divided by 480 is, oh no, not divided, minus, is 240 equals 8x, and then divide by 8, and x is going to equal 30. So the distance from the poster to the edge of the frame is going to be 30 centimeters. It asked me for the dimensions of the frame. And so remember the dimensions of the frame here, we said we're going to be, the dimensions were going to be 100 plus 2x, all right, for the length, and then for the width, it was going to be 140 plus 2x. So I'm just going to plug in my answer of 30 there. So 100 plus 2 times 30 would be 160 by 140 times 2 times 30. So 140 plus 60 would be 200. So the dimensions of the poster are going to be 160 by 200. That's usually how they list dimensions, is like length times width, like that. All right, next up here, it says we have a rectangular lot that is 8 feet longer than it is wide. So I would just draw a rectangle here. I would make this one x, and then 8 feet longer than x is not 8x, it's x plus 8. And they told me the area is 2,900. So what I would do here is I would set up an area formula. So area equals x times x plus 8. Okay. And actually, I would not put, instead of putting area right here, let's go ahead and fill out our what our area actually is, which is 2,900. And so since area equals length times width, I just filled out the 2,900 for area, x for length, and then x plus 8 for width. Okay, so I see that this is factored, but it's factored equal to 2,900. I never want that. So I'm going to go ahead and distribute that. And then I'm going to subtract the 2,900 over. So I can get one side to 0, because I only ever want to factor equal to 0. So now I need to think of two numbers that multiply to negative 2,900 and add to 8. Now that seems pretty intimidating here, but whenever they have like a big number that's a multiple of 10 that ends in a 0, I always kind of notice that, or not always, but I usually notice that it's going to be some multiple of 10. So instead of checking every number, I would just check multiples of 10. So obviously we could do 10 times 290 here. That doesn't add, it doesn't subtract to 8. So let me try another one. Let's try it divided by just 20. So I can do 20 times 145, still doesn't subtract to 8. 2,900 divided by 30 is a decimal. 2,900 divided by 40 is a decimal. 2,900 divided by 50, though, is 58. And so that will work if I do a 58 and a negative 50. Now, we have no number in front of the x squared, so I can go ahead and use my shortcut here. So I can write x plus 58 and then x minus 50. Okay, so that means that x could equal negative 58, x could equal 50. Now, since this x represents a distance, we're going to ignore answers that are negative distance, because distance cannot be negative, because whether you're going 58 feet longer in any directions, it's still a positive distance. And so I'm going to say x here is 50, and so that really is represented right here on the rectangle. It asked me for the dimensions, so if x is 50, then this other one must be 58. And so the dimensions, once again, would be 50 by 58, which they would, once again, show with like that x in the middle. That's how they say it, and you would read it like 50 by 58. All right, next one, another rectangle problem here. So they say area of the rectangle is 52 square centimeters. And then they say the length is 1 more than 3 times the width. So we'll call the width x, and then 1 more than 3 times the width. So for that, 3 times the width would be 3x, and then 1 more than that, I would just put a plus 1 at the end. I would always say you should put the plus 1 at the end when it's 1 more than. Even though we say that first, it really should come after. When it's addition, that doesn't really matter, but if it said 1 less than 3 times the width, we would have to do 3x minus 1. 1 minus 3x wouldn't work. Okay, so now I'm going to do it just like I did the last one. So 52 equals x times 3x plus 1. It's factored but not equal to 0, so I want to get one side to 0 and go ahead and distribute that x in there. So 3x squared plus x minus 52. All right, so now we need to factor here. A times c, 52 times 3 would be negative 156, and then the bottom is 1. So what multiplies to make 156? Well, it's even, so I can divide it by 2. 2 times 78, obviously not going to make 1. 156, I think it is divisible by 3. 3 times 52, not going to work. 156, it probably is divisible by 4 as well. Yeah, 4 times 39, not going to work either. Not divisible by 5. It is divisible by 6. 6 times 26, getting closer here. I don't think it's divisible by 7. Nope, that's a decimal. Divisible by 8. Nope, that's a decimal. 9, no, is a decimal. 10 is obviously not divisible. Is 11? I don't think so. 156 divided by 12. And there it is, 12 times 13. Okay, so we'll do a positive 13 and a negative 12. Now this one I cannot use the shortcut. I have to, since we have this 3x squared out front, I have to rewrite that here. I split up this middle term using my x, so it's going to be plus 13x minus 12x, and then minus 52 brought down here. Now I'm going to do the grouping technique. So the first group, I can just take out x, which leaves me with 3x plus 13. The second group, I'm going to take out a negative 12, which leaves me with, oh no, I can't take out a negative 12, excuse me. I can only take out a negative 4, which is going to leave me with 3x plus 13 as well. Okay, so that means it's x minus 4 times 3x plus 13. Okay, so that's equal to 0, so x could equal 4. And then this one would be 3x plus 13 equals 0. So 3x equals negative 13, and then x equals negative 13 over 3. Now once again, we're going to ignore the negative answer for distance. That means that x is 4. So I can put that over here. And then 3 times 4 plus 1 would be the other dimension, so that would be 13. Okay, now this one asked me for the perimeter. So my final answer for perimeter, remember we learned, was 2L plus 2W. So 2 times 4 plus 2 times 13. So 8 plus 26 would just be 34.